Assalamualaikum. We are from Group 10. My name is Morrisdin Osman, metric number TCY044. And my partner is Muhammad Shamsul Hasrin bin Chaisi, metric number TCY030. We would like to present about CAV and VAV system in HVAC. We move to the first part. Introduction of CAV and VAV. Constant air volume CAV system is a type of HVAC system that usually used in all buildings. The flow rate of air supply is constant, but the temperature of air supply is varied to meet the thermal load of a space. Most CAV systems are small and provide a single thermal zone. However, variation of CAV such as CAV with reheat, CAV multi-zone, and CAV primary secondary system can provide multiple zones and larger buildings. There are two types of CAV system, which is the terminal reheat system and the mixed air system. For variable air volume valve system is a type of HVAC system that commonly used in a modern office building. Compared to CAV system, VAV system supply a constant airflow at variable temperature, and it vary the airflow at a constant temperature. We move to the next part, how CAV works. The CAV design will work very well if all the rooms are of a similar condition or require a similar cooling heating condition. But if a room has a different cooling heating load, then it might need to be connected to a different AHU, which is air handling unit. Depending on the size, it might be better with own AHU supply. One way around this is to install the terminal reheaters. They are usually found in a metal board in the ceiling before the diffuser. Typically, these are electrical heaters. It could also be from the hot water system. This will reheat the air up to a higher temperature, but obviously that is very energy inefficient because it already cooling the air down the AHU, and now it paying again to heat the air back up. The air temperature for this type system is supplied at the coldest temperature possible, and that suits the room with the largest cooling load. Two ducts running and supplying the rooms, and one of them will provide a cool air and the other one will be supplying warm air. This air then mixed by some damper in a box at each room just to suit the temperature inside. The return air is then also returned back to the AHU, ready to be recycled or dispersed out to the atmosphere. This system gives a much improved thermal control, but there is a little control of humidity. Again, it's not particularly energy efficient either. As you are supplying air through two streams, you have a lot of resistance which the fan is going to have to overcome.
Now we move to the how the VAV works. Actually, VAV allows zoning with the buildings. That's ideal for the most situation because every room is a building will experience a slightly different between heating and cooling load. VAV system is allow each room to control the amount of the cooling and the possibly heating individually. Each room is supply the same main AHU and the conducts. The different part of the buildings may have a dedicated AHU and also the duct. The example of the south and the north side of the building are selected floor depending on the functional. The AHU is seated in the mechanical plant floor room. And also coming off the two ducts, the supply duct and the return duct. Both ducts are run through the buildings, taking the shortest route to deliver the conditioned air to the rooms. The supply duct provides the air, and the return duct sucks out the dirty used from air. In the VAV system, the air is supplied from the AHU at around 13 degrees Celsius, which is the 55 degree Fahrenheit. The air flow along the main supply duct and distribute into the room. Once the air has provided heating or cooling, it will be sucked back into the return duct and flow back to the main AHU. On the back of the VAV, the inlet, we can find some tube forming across the shape. This is an airflow sensor. It is measuring the change in pressure across the devices. From that, it can calculate the average air velocity and thus the flow rate into the VAV terminal system. Therefore, the front is going to have the high pressure side, and the back side we have the low pressure point. You can find the differential pressure across the devices if you average that for the size of the duct and calibrate it. Then you can calculate the flow rate of the air entering into the box and the zone. The damper never closes fully because it needs a certain amount of the fresh air to enter into the space. Move to the advantage and the disadvantage of the CAC and the VAV system. A CAC system, by nature of its design, use a higher energy because it is a release of constant high flow of air, and also consequently a higher energy output. The CAC system may still be an effective option in the commercial space with the single zone that have less variety and the air temperature. However, in buildings, the multiple heating and cooling zone using the old CAV heating and the cooling system will most likely result in the higher energy bills and less effective temperature, humidity, and also the ventilation regulation. This is for the CAC, and we move to the VAV system. A VAV system is basically more energy efficient and is more precise in delivering the required airflow to different zones. The fan and the compressor operate at variable rates to accommodate the temperature requirement of each zone, thereby it going to reducing the amount of work the component are tasked to perform, and also the amount of energy utilized to achieve those temperature, and the ventilation and also the humidity of the elements. In conclusion, HVAC engineering can choose between CAV and also the VAV system depending on the application. While a CAV system is used the variable air temperature and the constant airflow, a VAV system keep a constant temperature and variable airflow. CAV systems are better suited for the single zone application where the load experience little change, while the VAV system are the best option for multi-zone application with a constantly changing load. If the facility physical space has grow over time and you are now operating the multiple heating and the cooling zone, it might be appropriate time to change this VAV system to a more efficient and cost saving VAV system. VAV system have been shown to save as much as 20 to 30% in your utility and also the maintenance repair bill. I think that's all from us. Thank you.